Hello, my name is Alex Kazarian, and this is my science fair project, where I'm trying to figure out in which environment catalase enzyme works best. My hypothesis is, if catalase enzyme introduced in the neutral pH 7 environment, they are providing the best protection of the cell from oxidative damage by reactive oxygen. My ingredients, my materials are 5 clear glass containers of equal size, permanent markers, tape. We need 5 clean spoons in distilled water, small cup, baking soda, set of measuring teaspoons, measuring cup, hydrogen peroxide, dry yeast, a ruler, and lemon water. Our preparation is we have to label the containers 1 dash control, 2 dash low acid, 3 dash high acid, 4 dash low base, and 5 dash high base. Number 2, put a spoon in each of the containers, which we did. Pour a 1/2 cup of distilled water into the cup. Add 1 teaspoon of baking soda and stir it until it dissolves. I'm going to do that right now. There, I think it's good. Let's pour a little bit out. I think that's a bit too much. I think that's perfect. Pour it in like so. And just stir it until it dissolves. Alright, now I am finished. Alright, next we have to create the pH 7 neutral. Add 2 teaspoons of distilled water to container 1 control. So, I'm going to take this water we just mixed, into this container. Is it 2 teaspoons? Okay. Now we have to stir in 1/4 cup of hydrogen peroxide to the container 1 control. So we have this. We have this 1/2 of a cup. Okay, as you can see, I have 1/4 measuring spoon and then hydrogen peroxide. I'm gonna pour this. Oh God. Pour this inside. It's starting to bubble a little bit, I think. Right, next we have to stir in 1/8 of a teaspoon of yeast. So we got a 1/8 right here. We don't have a 1/8 of a teaspoon, so over here we have 1/4 of a teaspoon, so we're only gonna grab a half of it. Is this good? Okay, that's good. And we're gonna add it into the water. Okay, see, it's starting to bubble. Okay, so now we have to stir in. Now I'm gonna place the ruler aside and then see how big we're gonna see in centimeters how big the reaction is. Oh, it's getting bigger. I think it's gonna overflow. Going 7. Oh God. 8. Oh, almost. Not yet. It's going 8. Oh my God. Do I continue stirring? 9. 10. Oh, it's gonna overflow. 11. 12. Oh my god, I think this is the one. 13. It's almost at 14. Nope. It's not going 14. I think that's it. Well, this is it all calmed down now. And in total, we had number 1 control in 13 centimeters. So next, we're going to create the acid-treated containers. We're going to add 1 teaspoon of lemon juice to container 2 low acid. So we're going to find container 2, which is right here. We have to write down container 2 low acid. But you probably can't see that because of the resolution. We have 1 teaspoon right here. I'm going to open this up. Nice sour lemon water. Okay, there we put it inside in a little mess. Add 1 more to number 3, high acid. 1 and 2. I think that was a bit too much. Alright, next it says to add 1 teaspoon of distilled water to container 2, low acid, so it is the same volume as container 3. So we have a teaspoon of distilled water right here. Add this to number 2. Next up, we have to stir in 1/4 cup of hydrogen peroxide to container 2 and 3. So here I got the hydrogen peroxide. Let's start with number 2. Okay. Economy. And then finally, cup here. Okay. Next, we have to add, half of 1/4, which is 1/8 teaspoon of yeast to both container 2 and 3. It's probably gonna be even a bigger explosion. Okay, we're gonna add this to number 2. Okay, starting to bubble up. Then we're gonna hurry up and put in the other one. Alright, we're gonna stir this really fast. It's not as bad as the other ones, at least number 3. On the ruler for number 2, we have, see from here, okay, for number 2, we have 7 centimeters, still going up. And for number 3, we have only 3.5. Oh, record 2, it's getting bigger. Three is kind of small. Let's go number 2. Yeah, this one is almost close to the other one. This one is at 8 centimeters. Actually 9. So all I know is that 3 is not safe whatsoever. Is that 10? I don't recommend doing number 3. It's like, well, the lower, the worse. Oh, go back. Let's go to number 2. Might actually catch up. gonna prove my hypotheses wrong. It's at 11. I think it's gonna go up to 12. I think that's it actually. Yep, it was 11. Final answer. And this one, 4. Safe. All right. So for number 2, low acid, we have 12 centimeters. And for number 3, high acid, we got 4 centimeters. Not safe at all. Okay, so in the next one, we're going to be using 4 low base and 5 high base. So first off, we're going to add 1 teaspoon of baking soda solution to container 4 low base. So I'm going to get a teaspoon. Number 4. Yeah. Alright. Now we're going to add 2 teaspoons of the baking soda solution to container 5 high base. 1. And 2. There we go. Now we're going to stir 1/4 cup. We're going to add 1 teaspoon of distilled water to container 4 low base, so that is the same volume as container 5. The water right here. Alright, now it should be equal. And now next, what we have to do is stir in 1/4 cup of hydrogen peroxide to containers 4 and 5 again for like this 3rd time. Funny one. Add 4 like so. Hope it doesn't go crazy early. And number 5. Okay, next we have to stir. Alright, now we have to add, again, 3rd time, 1/8 of a teaspoon of yeast to both of these, and then record the reaction and stir as fast as we can. Okay, add number 4, and bubble up. And number 5. Just stir. Okay, starting to add up. Number 4 is going pretty as high as 2 really early. Okay, it's number 4 is at 10. No, number 5 is at 7. 11 for number 4, 7, 11. Uh-oh, it's at 12. No, it's not at 12. It's at 12. I think that's it for number 4. I think.